So the log laws are fairly straightforward. There are these three basic ones. And I guess you don't, they're used in both directions, if that makes sense. So if you've got the log of a product to a given base, you can write it in this format. However, you'll often find you come across logs written in this format and you'll want to simplify them, so you're actually using the law in reverse. So if you see this situation, then now you can replace it with log of the product of the numbers to the same base. Obviously, the bases are the same, so the bases are the same. So it's like the log of a product to a given base is the sum of the individual numbers also to the same base. So there's this connection between the product and adding the logs. We know that if we had a product of terms when you had a to the x times a to the y, same base, you added the indices. It's like now we've got the log of a product of two numbers to a given base, you add the logs. If you've got the log to a given base of a quotient, x over y, then we subtract the logs of the top minus the bottom. Again, it's a little bit like indices, top index minus the bottom index. So when you've got x to the 9 on x to the 7, we subtract the indices. We're taking the log of a quotient and we're subtracting them. And if we've got the log of a number to a power to a given base, then we multiply the power and the base. Now this is really commonly used, really common, to take the power out, place it at the front and multiply by the log. So these couple of examples will demonstrate the rules. So this is a situation where we've got log of 16 to base 8. Now I don't know what to raise 8 to in order to get 16, nor do I know what to raise 8 to in order to get 4, but I could use the first rule in reverse to write this as the log to base 8 of 16 times 4. Now, this is going to nicely pan out. 16 times 4 is 64. So what I'm actually looking for now is the power that you raise 8 to get 64, and we know the answer to that is 2. So while I didn't know the individual logs when they were written in this format, I could rewrite it, and without a calculator, I could find the simplified answer. Obviously on this one we're not going to come up with a numeral answer, but let's see what we can do here. We could, well, we actually can't do anything until I remove that 3. So I can rewrite this first term as the log to base x of y cubed minus, and remove that 2, which is the log of z to base x, which is nice, they've got the same bases, and that z is squared. My z's and 2's look the same there. Now, once I've got the log to the same base in each one of those, I can use the reverse of the second law and put those together and say it would be the log to base x of y cubed over z squared. And yeah, like I said at the beginning, we can't come up with a numeral answer, but we have certainly simplified it. Here we're being asked to solve. So first one was evaluate, Second one was simplify. This example is solve. So we're finding the value of x, we're finding the value of this pronumeral. I guess the nice thing about this is that everything is to base 4. And as with any solve question, we're going to try to get that x by itself. So let's move the log of 3 to base 4 over here. So we would end up with log to base 4 of 9 minus log to base 4 of 3 is equal to log to base 4 of x. And looking at this, I could put those two together using rule 2 or law 2 in reverse and say that's log to base 4 of 9 divided by 3, which is 3. And I'm looking to find x. Now, another solving technique is if we set up an equation and the left-hand side is in the identical format to the right-hand side, then we know components of the expression must also be equal. So we're taking log to base 4 of both sides, and I can conclude that x must be equal to 3. So there are some different applications of the log laws.